Welcome to Lecture 1 for your Physical Geology online course. This lecture video will cover the basic elements of Canvas in this course, how you will use these, and then we will have our lecture on latitude and longitude. So here we are loaded up into Canvas. You can see we have the course syllabus here. You have all the different information available when you can contact me when I have office hours, dates for exams, and how the class will be broken up in terms of homeworks versus tests. So in Canvas, all of your assignments will be submitted online. You won't email me any assignments, you will upload them. So every week you will have both a homework assignment from our lecture, and because it's a laboratory course, you will also have a lab to complete every week. So lab 1 is on the scientific method, and this is just a brief introduction to get you to understand the methods that scientists use in order to progress their research and how hypotheses can evolve through time from basic observations to well-established theories. So within the course here, you have a couple of items that are at your disposal. Announcements are very important. So if you have a smartphone, you can download the Canvas app. And I recommend you should do this because every time an announcement is made, or a homework assignment is posted, or a lecture or lab is posted, you'll get a notification that will pop up on your phone. And I always make sure that these notifications go through after posting. If you happen to miss the announcement for whatever reason, you should make sure to be checking Canvas regularly, just to make sure you didn't miss anything. So you can find announcements here. It's my way to communicate with the entire class. Then you have your assignments folders. We also have the discussion board. So we had an initial exercise with this in order for us to get to know each other. Since we're not doing face-to-face classes, it's nice to get a feel of your peers. And then of course you can come down to grades and you can check your grade. And that weekly progress you can keep track of to make sure that you're able to get the grade that you'd like to in the course and that you can stay on top of all the material here. So within an assignment, you will be linked to different videos. So for example, the scientific method within this lab, you can see here, you had linked to both text material. So here's the textual material, as well as that same material in a visual format. So whichever style is easier for you to learn, if you don't prefer to have someone speaking at you and you prefer to read and absorb information that way, but just for your information, it's the same material. So you'll always have these videos referenced and linked to the YouTube channel, and you can subscribe to that as well. So oftentimes there'll be several, there may be 4 or 5 of these videos. Don't skip over any because they're all important, they're all relevant, and I try my best to only assign videos that I think will really help you learn and grab your attention, and try to steer away from ones that are a bit older and a little more dull. So make sure you are engaging with the material. And I recommend that you take notes. So you have the lecture slides here. So you can, if you have the ability to print them out, you can do that. Or you can load the slides up into your computer or your tablet, take notes on them that way. Or, traditionally pencil and paper, you can take notes along with the video. As you go, you can stop it, pause it, take notes on the important elements. And if you're curious about what are some of those important elements that you should be focusing on, if you come in here to files, you will see we have study guides. So here is your first exam study guide, exam 1. So this is what will be covered on the exam. So it won't be all of this information. It will be some of this information, but all of it's fair game. I won't ask you anything that's not on the study guide. So you can use this as well as you go along with the lectures. Have it with you so you can pay attention. And when you see these vocabulary words, you can recognize them in the lecture material and sort of fill it in as you go along. but your weekly Canvas assignments will be the most helpful. So your multiple choice quizzes that you will have about the lecture videos that you will watch and take note of, that will be mainly what your exams consist of. So if you do really well on the Canvas assignment quizzes, the homework assignments, they're under quizzes, but they're just homework assignments, so don't panic. So if you do well on these, you will do very well on the exams. They're very, very similar. So those are the basic elements here of Canvas. So by now you've had a look through your first lab. You've learned about the scientific method and the processes involved. And you've had a look through the syllabus as well. My name is Sadie Balika. I'm a tenure track professor at Citrus College, and I have my PhD in geology and geophysics from the University of Western Australia. My research involved looking at the paleomagnetism of rocks and incorporating that with ancient supercontinents and their movements around the Earth over time. So that's my background, is in plate tectonics. So as we go through this here, I'll spend extra time helping you guys grasp this concept so that you can apply it to whatever field that you may choose to go into. So from the scientific method, now we can sort of get into more of the earth scientific aspect, now that we have this sort of basic understanding of how all science works. So Earth, as you know, right, is a sphere. And if you didn't know that before, now you do. But because of that, because Earth is a sphere, it used to be quite a challenge to map. And we didn't have satellites to precisely pinpoint our location on the planet. And so because of that, we had to develop a special coordinate system known as latitude and longitude. So this is like a grid that you can superimpose on a sphere in order to give yourself a precise location. So we oftentimes think of humans as only being sea-bearing for the last couple of hundred years, but as you know, as a matter of fact, human beings have been exploring the oceans for tens of thousands of years. And one of the oldest evidence, or the earliest accepted evidence of global seafaring and mapping, early mapping of planet Earth, actually comes from Australia at around 65,000 years ago. So to give you some perspective of where that sits in Earth history, around 200,000 years ago, that's when Homo sapiens developed in Africa. And then around 70,000 years ago, a group of African people moved into Asia. And then at around 65,000 years ago, there's the evidence of the Aborigine, which was the first population of humans outside of Africa, and they arrived to Australia. So in order for them to have traveled this distance to reach that continent from the Southeast Asian mainland, they had to go, across a 600-mile long band of islands and at least 10 ocean straits, which is, if you think about it, a pretty remarkable feat for that time period. And so I also want to stress that this is the best evidence we have, 65,000 years ago. But down here I have an article that you can read through if you'd like. It's pretty interesting, and it talks about some even earlier evidence than that, from archaeological sites in Greece, where they found shipbuilding axes from something like 130,000 years ago. But that's still a hypothesis, right? It hasn't been confirmed and reconfirmed, and there isn't a scientific majority, right? It's preliminary, positive scientific results. But the earliest well-supported evidence is around 65,000 years ago. So long before we had satellites, before we even had a compass, right? Human beings were seafaring and mapping the planet Earth as best they could and spreading out. And a lot of students ask, why were humans so ready to get on the move and explore? And it's because we have ADD. We can't sit still. We like to get out. We like to explore. And so because of that, humans started to spread around the world. And so if you're interested in archaeology, that's a really pretty interesting area that you could go into. So in order for us to precisely navigate where we want to go, we have to use the two quantities, latitude and longitude. And I'm sure you probably have learned about these before, but of course I'll go through them again as a sort of reminder because they're extremely important in this course. Anytime I'm referring to a region of the planet, and I say northerly latitude or polar latitude or equatorial latitude, you have to know what that means. So latitude, the technological definition is that it's the angular distance measured north-south of the starting line or equator from the center of Earth. So the equator, which is where Earth is widest, that is 0 degrees. And the north and south pole are respectively 90 degrees north and 90 degrees south. You can also use these terms as negative or positive. So the North Pole, you could just write plus 90 degrees and leave out the north. And the South Pole, you could also write minus 90 degrees and leave out the south. So plus corresponds to north, minus corresponds to south. So latitude and longitude max out at 90 degrees north and south. So with latitude, we have difference in the lengths of the latitude lines. You can see they get shorter and shorter as you move closer to the poles because Earth is widest along the middle. Latitude itself was calculated a lot earlier on than longitude. And that's because the North Star can be used as a reference point because it sits over the North Pole, so it's fixed. It's the stable reference point, whereas everything else seems to move around it. So because of that, ancient seafarers could actually calculate their latitude pretty accurately. So remember that latitude lines, they may run east-west, but they're a function of how north or south you are on the planet, right? So the North Pole and the South Pole, right? That's a reflection of how far you are from the middle of the planet. So latitude was something that it could be determined using a device known as a sextant. So this device measured the angle between a celestial object and the horizon. And so this device is actually still kept on ships that go out into the ocean. Of course, they don't navigate using sextants anymore, but they still have one as a emergency precaution. What if something happens to the satellites? They need sort of basic fundamental tool that they can fall back on when technology fails them. So Pytheas developed this method to determine latitude, and once the circumference of Earth was calculated, latitude was able to be determined pretty accurately. But the problem for a long time wasn't with latitude, it was with determining the longitude. That's what the ancient seafarers had the most trouble with. So longitude is the opposite of longitude. So it's the angular distance measured east or west of the starting line from the center of Earth. So up here you can see these are the longitude lines. They run north-south, and you may notice that they are all the same length. Whereas with the latitude lines, they were all different lengths, right? They get shorter as you move north or south. So that's because Earth is widest around the middle. But longitude, however, all the lines are the same length. But longitude, for this, you need to know the time, right? So for the reference point with latitude, we said the equator is our reference point. That's 0 degrees. So what's the 0 degree line for longitude? We chose the middle of planet Earth here for latitude because that's where it's widest. But because all the lines of longitude are the same length, where do we decide to put 0? And the answer is that it was just a completely random, arbitrary decision to make it in England because of the Queen. And that's it. There's really no other reason. And so that's where 0 degrees falls. It's called the prime meridian. So longitude is measured up to 180 degrees east or west of the prime meridian. Halfway around the globe, this is known as the international dateline. So with longitude, the problem was that sailors needed to know the time at their origin and also the current time on the boat in order for them to calculate the longitude. And at that time, this was in the 1700s, the only timekeeping device they had was a pendulum. Right? So what happens when you go out into the ocean with the pendulum? The waves are bouncing around. You don't know what time it is, right? And at the origin location, right, they need to know that time as well. So that was the main issue, was that they needed a solid timekeeping device. And so the king decided, he had a contest and he wanted somebody to invent a timekeeping device that could survive a long seafaring journey. And so the chronometer, or you guys may know it as the watch, this was invented by John Harrison in 1736. And so he expected to collect his prize money from the king, and actually the king was kind of a jerk and refused to give him the prize money until he perfected the model. And it wasn't until his deathbed that he finally got the prize money. So it just teaches you a lesson. Right? Don't take a contest from the king. But ocean navigation now is much simpler. We know today that we have something called the Global Positioning System. It was initiated in the 1970s by the U.S. Department of Defense. And GPS relies on a system of 24 satellites that send continuous radio signals to the surface. And the position is determined by accurate measurements of the time it takes, right, of the travel of radio signals. And you need at least 4. You need at least 4 signals so that you can accurately determine your location. And so I put here, we have it so easy because oftentimes we tend to forget the challenges of our ancestors and how hard they had to work to just map and get around the earth.